All features, bug fixes, and even new systems all start at their core with an idea. And the nice thing about an idea is it's really easy to think about, right? This is just a simple sentence. Fix this bug, add this feature, make a new game, right? These are simple high-level ideas. But when we want to go and build this into a software system, we need to make it more concrete, right? We need to add more detail to make this be a possible task, right? And this often requires multiple different layers of technical representation. So the first thing that we want to do with an idea is we want to transform it into a specification. Right, and this is something that we've seen before, right? Where we're going to take an idea and into a specification, right? This is just like user stories, right? So we're going to go and take our idea and we're going to flesh it out in the form of a spec so we have a better idea of what we want to build. Now in this process, we'll often learn things that will cause us to go back and modify the original idea, right? This is an iterative process, right? Because by making this idea more concrete, we will learn things and we'll figure out things that might be inconsistent or things that are harder than we expect or that weren't fully captured in the original idea, and we'll go back and we'll modify the idea. Now, once we have a specification that we're pretty happy with, we need to go and again come up with a new technical representation and transform it into that so we can start to think about how we're going to build the actual system. And this next level down is the design. Now, transforming from the specification to the design is pretty challenging work, right? Because the specification is in more of a plain text type domain, as is the idea. But the design is much more concrete. When we're looking at the design, we're thinking in terms of UML diagrams or some other type of diagrammatic representation. Right? So moving from this domain down into design is pretty challenging. But again, just like up here, this is also an iterative process. Right? We will learn things by creating the design that might have to go back and feed back into our specification, leading to other changes. Right? So we need to go and deal with this step as well. But our design isn't enough. Right? We can't execute a design. So we need to go and come up with another representation still, and that's the code. Now the code is, just like here, right, is in a different design space, a different representation space than the design, but it is still closer. Right? When we go from design to a code, we have our classes, we have our fields, we have a general idea of what we're doing. Right? So this step is often less challenging than managing the transition between specification and design. But again, still, once we go and implement this low-level representation, we'll go and learn things. We'll figure out that we had shortcomings in our design that's going to have to feed back into the design so that we can reason about whether or not the whole design that we have makes sense. So as we move down these layers of technical representation, what we're really doing is we're making things more concrete. And conversely, as we move up these layers, we're making things more abstract. Now, it's not that it's easier to make things more concrete or easier to make things more abstract. Right? They each have their own challenges. When we're going and making things more concrete, we're essentially having to fill in details. We have to make up novel pieces of information. For instance, when we go from the specification to the design, we need to figure out what are our classes? What are our methods going to be? What public fields will we have? And when we go from the design to the code, we need to think about, hey, what private methods are we going to have? What algorithms will we be using? What private types of data structures? But when we try to do design recovery from code, we also have other challenges. Right? So if we're looking at the code and trying to figure out what the design was, if there wasn't an explicit design in the first place, we need to figure out which details do we want to show and which ones should we hide. And in this case, we can see the real challenge of going up the abstraction hierarchy. Moving from the design to the specification is a really challenging task. Or given a big UML diagram, how can we figure out what it actually does, what the specification was? Right? So this can be really a challenging process. Right? So there are challenges both in making things more concrete and more abstract. But the one thing to keep in mind is that there really is iteration within each of these steps that we need to think about. The other thing to keep in mind is that each of these different types of technical representations have different stakeholders that are interested in them. Right? So if you're the product owner, you're obviously extremely interested in the idea and the specification, but the design and the code are much less interesting to you. And if you're, for instance, a QA developer, you're going to be interested in the code and maybe the design, but the idea and the spec might be less interesting to you. Well, I guess actually, if you're a QA person, you're going to want to be building your tests from the spec, but the scope of what you care about will be different. Right? So these different representations provide different value for different stakeholders, and every system will have multiple layers of technical representation that'll be used to help provide clarity on what the system is, what the system does, and how it should be built.